Okay, so we're doing lesson 97 today. Angles and triangles, Pythagorean theorem, and Pythagorean triples. So if you look at the bottom of the first page, it's just showing you what happens when you intersect two lines. Okay, you get 4 angles. And it just happens that A and C are equal, B and D are equal. Okay, they don't tell you that on that page, but they are equal. Those are vertical angles. On page 406, it says if you look only at angle B, and these are lines, so they keep going. So angle B is formed by these two rays, and this part of line 1 and this part of line 2. So the interior of angle B is anything that's in here. Anything that's on the outside of these two rays is the exterior of the angle. So the interior is inside of it, and the exterior would be anything on the outside of it. They also show you that an angle is formed by two half lines or rays. I really don't like the word half line because a line goes to infinity in both directions. So how do you take half of infinity? But I guess they mean half line because it only has one arrow. It's only going to infinity in one direction. So that's always been something that, what happened? Are you guys still there? I hope so. It's always been something that's bothered me. But I guess you show it just because if you see it on a standardized test sometime, then you'll know half line means a ray. Okay, so if two lines intersect and they're perpendicular to each other, then they form 4 right angles. And each angle is 90 degrees. All the way around is 360 degrees. Then next thing that they cover is the sum of the measures of any triangle on the interior. So inside the triangle, the sum is always 180 degrees. Doesn't matter what the shape of the triangle is, anything, it's still going to be 180 degrees on the inside of that triangle. So down at the very bottom of the page, they give you examples. The first one has a right angle, so we know that's 90. Plus the other 60 plus 30 is 90. That makes the 180. The next one is an equal angular triangle, so all 3 of them are 60. 3 times 60 is 180. And then the last one is an obtuse triangle. If you add all those up, see 135 and 25 is 135 and 25 is 5 and 5 is 10. 160 plus 20 is 180. So they all add up to 180. Then at the very bottom of the page, it tells you that the triangle on that left was a right triangle because it has a right angle. So when you have a right triangle, special things happen. Okay, a right triangle. First of all, if I gave you that picture and I told you that this was 20 and asked you to find out what this is, there's no reason for you to add 90 plus 20 and then subtract it from 180. 90's already used up here, right? 180 minus 90 leaves us with 90 for these two angles. So if this is 20, this one has to be 90 minus 20, which is 70. Okay? All right, now then, in a right triangle, we have special names for things. That's the right angle, obviously. The side that is directly across from the right angle is called the hypotenuse. Okay, the other side are just called legs. It doesn't matter which one is which. But the one that's important is the hypotenuse. And the hypotenuse in a right triangle is always the longest side of the triangle. Okay, so the next thing we're going to cover is the Pythagorean theorem. It only applies to right triangles. So if you don't know you have a right angle, you can't use it. The sides are A, B, C. Hypotenuse is C. So the Pythagorean theorem says A squared plus B squared is equal to C squared. Remember it, A squared plus B squared equals C squared. Now, without doing an exact drawing here, I want to show you what that means. If you draw a square here that has the length of side B, in other words, all of these would be B. Over here, you draw one that has the length of A. And I can't show you this one because it's going to go off the page, but it would be like that, and this would be C. You count all the little squares in here, count all the little squares in here, add them together. That's the A squared plus the B squared. And then you count all the little squares over here in the C squared. This plus this little one plus this little one would be equal to the big one. So that's where the theorem comes from. A squared plus B squared equals C squared. Okay, only applies to right triangles. All right, so example 1 says to find A. 5, 4, A, right angle. Okay, so the first thing that we have to do, most important thing, is to identify which one is the hypotenuse. Remember, the hypotenuse is directly across from the right angle. So there's the hypotenuse. So write the formula, A squared plus B squared equals C squared. The hypotenuse has to go here for C. So this has to be 5 squared. Over here, these can go in any order. It could be 4 squared plus A squared or A squared plus 4 squared. That doesn't matter. Okay, so now we have A squared plus what's 4 squared? 16 equals what's 5 squared? 25. Okay, I'm just going to put this over here. A squared plus 16 equals 25. So we're going to subtract 16. A squared is equal to 9, which means A is 3. Okay? All right, next one. Oops. Right triangle, it's laying on its side, so it's like this. Here's the right angle, which means the hypotenuse is right here. That's P. This is 4 and this is 5. Okay, so which one is the hypotenuse? It's the one across from the right angle. So the P has to go in here for C. Okay, the other two don't matter. 4 squared plus 5 squared. So 4 squared is 16. 5 squared is 25. And then what is this? 41. And we don't know the square root of 41. So at square root of 41. Okay? All right, for that one, next, find K. So this is an upside down right triangle. K, oops, 5, square root of 61. The right angle is here, so the hypotenuse is here across from it. A squared plus B squared equals C squared. 61, square root of 61 has to go over here, and it's squared. And then we can put K squared plus 5 squared. All right, so that's K squared plus 5 squared is 25. And now what is the square root of 61 squared? What's the square root of 2 times square root of 2? It's 2. So the square root of 61 times square root of 61 is 61. Okay. All right, now we work it. And what are we going to get? Subtract 25. So K squared is equal to 11 minus 5 is 6. 5 minus 2 is 3. So K is equal to 6. All right. Okay. Next. This guy's laying kind of crooked. That's the right angle. So the hypotenuse is over here. That's 12, that's 8, and that's m. A squared plus b squared equals c squared. The hypotenuse has to go in for c. So what do we have to put for c? M. So m squared. The other two legs are a and b, so 12 squared plus 8 squared. 144 plus 64 equals m squared. What is that? 8, 6 and 4 is 10, 208. Okay, so 208. Take the square root of it, it's square root of 208. Now we need to figure out, will that simplify? So we got our list of perfect squares is 4, 9, 16, 25, 36, 49. That's probably enough. 4 goes in there for sure. 4 goes in here 52 times, right? But 52 breaks down also into 4 times 13. So it's 4 times 4 times 13. So actually, these two 4s come out as 1 4. In other words, square root of 4 is 2. Square root of 4 is 2. So that's 2 times 2, which is 4. And the square root of 13 stays underneath. So you just need to remember that if any radical, you need to make sure that you can't simplify it, because it will be wrong if you don't simplify it when it would. All right? Okay, so the next part is something that you just really need to memorize. There's one basic Pythagorean triple. There's actually 3 of them on page 409 up at the top. So your basic one is 3, 4, 5. So in other words, 3 squared plus 4 squared equals 5 squared. Okay, that's the basic Pythagorean triple. Another one that works is 5, 12, and 13. And then the last one they give you is 8, 15, and 17. If you can memorize those, it's going to save you a lot of work. If you don't memorize them, you can always use Pythagorean theorem to fill in the missing blanks. But if you memorize those triples, it's going to help you save a lot of time. So example 97.5 is this. 5, 12, and A. Okay, well that's this one right here. So what does A have to be? A has to be 13. Okay. The next one is B here, 8 here, and 17. And that was, what was that one? Oh, it was 8, 15, and 17. So there's the 8 and there's the 17. So what does B have to be? B has to be 15. Okay. Then next, okay, this one's a little different. There's a right angle, 6. Oops, sorry. I was looking at the answer. C, 8, and 10. Okay, well, we got those 3 Pythagorean triples. There's one of them. 5, 12, 13 was another. And the basic is 3, 4, 5, isn't it? So 8 and 10 don't fall in there, do they? But look at 3, 4, 5. If I multiply 4 times 2, I get 8. 5 times 2, I get 10. So C must be 3 times 2, which is 6. So C is 6. So the cool thing about Pythagorean triples is that you can multiply them by any number and it's still a perfect triple. So like 8, 15, and 17, if we wanted to look at that one. We could double this. It'd be 16, double that, 30, double that, 34. That's still a Pythagorean triple. That still works for a right triangle. So this one back here had 8 and of, I mean, it was a multiple of the 4 and the 5. So that's why I figured out what it was. 4 times 8 was 2, 4 times 2 was 8, 5 times 2 is 10. So if I take this 3 times 2, that gives me what the missing side was. Okay, sorry, I know that was a long video. Let's see, what do I want you to do? Principal at All Saints Roswell.com. And I love Pythagoras. He was the man that invented all of that. Pythagoras. Okay, guys, see you tomorrow.